In this video, we are going to learn how to solve rational equations involving word problems. Before we get into that, let's kind of go over some vocabulary terms that we've seen in the past. So question 1 says, what is the reciprocal? To find the reciprocal of 3 over 2, all we have to do is flip the fraction, and so the reciprocal will be 2/3. On example 2, it says, what is the reciprocal of 4? Well, 4 is like if I had 4 over 1. So if I reverse that, I'll have 1/4 as the reciprocal of 4. Remember that reciprocals, when you multiply them, you should get 1 if you have found them correctly. So if I do 3/2 times 2/3, you get 6 over 6, which is 1. And here, 4 over 1 times 1/4 is 4 over 4, which is 1. So that's the definition of a reciprocal. And then question 3 says, what is the distance formula? Distance equals rate times time. So D stands for distance, R stands for rate, and T stands for time. And we will be using this formula throughout today's lesson. So let's go ahead and look at example 1. It says it says the sum of a number and its reciprocal is 29 over 10. Find the number. Well, the first thing I read is the sum. Sum means that we are adding. The sum of a number. I don't know what the number is, so I'm going to let that number be x. You can choose whatever letter that you'd like for your variable. I'm choosing x. So the sum of x and its reciprocal. Well, the reciprocal of x would be 1 over x. Is means equals. Excuse me. So I'll have x plus 1 over x equals 29 over 10. So we have created a rational equation, and we can use this rational equation to solve this word problem. Your first step is going to be to find a least common denominator. For this equation, my least common denominator is 10x. So I am going to multiply every term by 10x. 10x times x is 10x squared. 1 times 10x is 10x, and then here my x's will eliminate, just leaving me with 10. And then here my 10's will eliminate and leave me with 29x. The next thing that I see is that I have a quadratic equation. To solve quadratic equations, you could use any one of the 4 methods we learned. I'm going to get it so that one side equals 0. Excuse me. So that I can solve by either factoring or quadratic formula. So I'm going to subtract 29x on both sides. And so I'll have 10x squared minus 29x plus 10 is equal to 0. This is factorable, so I am going to go ahead and factor that. I'm going to use the area model to solve by factoring. So first term goes in the first box, last term goes in the last box. You always need to multiply your first number by your last number. So I'm looking for 2 numbers that multiply to 100 and that add to my middle number of negative 29. Those 2 numbers are going to be negative 25 and negative 4. The greatest common factor of my top row is 5x. The greatest common factor of my bottom row is negative 2. Greatest common factor of the left column is 2x. And the greatest common factor of the right column is negative 5. So my factors are 5x minus 2 and 2x minus 5. I can solve this by using the principle of zero products and by saying 5x minus 2 equals 0 or 2x minus 5 equals 0. If I solve this first equation right here, I'll add 2 to both sides and then divide by 5 to get x equals 2/5. On this second equation, I'll add 5 to both sides and then divide by 2 to get x equals 5/2. If we're looking for excluded values, the only denominator that has a variable is x, so x cannot be 0. I did not get 0. I got 2/5 and 5/2. So the question said, find the number. Well, the numbers are 2/5 and 5/2. You'll notice that these are reciprocals of each other. So that means if you add 2/5 and 5/2, you will get 29/10. If we look at example 2, this is a distance problem. And so it says a boat can travel 32 miles per hour in still water. It travels 150 miles upstream, which is against the current, and then returns to its starting location. The total time of the trip is 10 hours. What is the speed of the current? So, let's see. Let me draw you a little picture. So here is the river, and then here is my beautiful boat. There we go. Now, when it says it travels 32 miles per hour in still water, that means without any current. This river has a current, and so when it is going upstream, so when it's going this way, it's going against the current. So the waves of the current is going the opposite direction. So if the boat is going forward at 32 miles per hour, then the current is going to be going in the opposite direction, slowing it down. When the boat returns, it's then going downstream. When it's going downstream, it's with the current. So the current is going to speed the boat up and make it go faster than 32 miles per hour. So when we're talking about our rate in these situations, your rate will always be your vehicle, whether it's a boat or a plane, plus or minus nature. And nature will be, your wind or your current. So vehicle could be plane, could be a boat. Nature could be wind or current, situations like that. So let's go back up to this problem and let's fill in this table that's right here because that's going to help us solve this problem. So 32 miles per hour is my rate. When we are going upstream, we're going against the current. So that means that the current is slowing the boat down and making it go slower. So we're going to be going the rate minus the current. And then downstream is with the current. So the current is going to make the boat go faster. So it's going to be 32 miles per hour plus the rate of the current. They travel 150 miles upstream and 150 miles downstream. We know the total trip time is 10 hours, but we don't know how many hours each way. Right? It's not going to be the same because you're going 32 miles an hour minus the rate of the current and 32 miles per hour plus the rate of the current. We said earlier at the start of this video that distance equals rate times time. Well, I can solve this formula for t. If I divide both sides by r, I'll have distance over rate is equal to time. So let me look at my equation here. Let's look at upstream first. Well, let me write this out. So the time it takes to go upstream plus the time that it takes to go downstream equals your total time. So let's look at the upstream. Upstream's distance is 150. Divided by the rate, which is 32 minus r. Plus the distance for downstream, which is 150, divided by the rate for downstream, which is 32 plus r. And that's going to equal our total trip time of 10 hours. This is our equation. From here, we can go ahead and find the least common denominator. my least common denominator is going to be 32 minus r and 32 plus r. So I'm going to multiply each term by that. 32 minus r, 32 plus r. 32 minus r times 32 plus r, and 32 minus r times 32 plus r. When I do that, 32 minus r eliminates with 32 minus r, and that's going to leave me with 150 times 32 plus r. For my next term, 32 plus r eliminates with 32 plus r, and that's going to leave me with 150 times 32 minus r. Equals 10, and then I can multiply this out, so I will have, let's see, 32 times 32, which is 1024, and then plus 32r minus 32r minus r squared. So let's go ahead and simplify this a little bit. 150 times 32 is 4,800 plus 150r, I'm just using the distributive property, plus 4,800 minus 150r is equal to 10,240. These are going to cancel, minus 10r squared. So let's take stock here. It looks like I'm going to need to go ahead and combine like terms on this side. So I'm going to have 9,600. And then 150r minus 150r is going to cancel. And that's going to equal 10,240 minus r squared. This is a quadratic equation. I can solve this quadratic equation by taking square roots. So I'm going to go ahead and do that because I don't have a b value. So that's going to be the fastest way to solve this one. So I'm going to subtract 10,240. And when I do that, I get negative 640 is equal to negative r squared. If I divide both sides by negative 1, I'll have 640 is equal to r squared. Now that I've isolated the square term, I can go ahead and undo the square by taking the square root. Oops. I just noticed. Let me fix that. This should have been a negative 10r. So I'm going to have to divide both sides by negative 10, not by just negative 1. And when I do that, I'll get 64 is equal to r squared. And then I can undo the square by taking the square root. Whenever you take the square root of a number, it's always plus or minus. The square root of 64 is plus or minus 8. So we have to think about what this means because we're doing this in terms of a word problem. So in terms of context, right? And so here, this is the rate of the current. Can the rate of the current be positive 8? Yeah, we could say that the rate of the current is 8 miles per hour. Could the rate of the current be negative 8? No, that wouldn't make sense to have a negative speed. So our solution is 8. Because that is what makes sense in the context of this problem. So the speed of the current is 8 miles per hour. Now, if you're saying, wait, we didn't check for excluded values, if you look at your excluded values, your denominator is r minus 30, or 32 minus r, and 32 plus r. Here you're going to get positive 32, and over here you're going to get negative 32. So when you do that, you can't have positive 32 or negative 32 as a solution. We did not get that here, so our excluded values do not have an impact on our solution. So this is our answer. It's a lot to take in the first time that you see it, but the more you practice it, the easier they become. What I would like you to do is go ahead and pause the video and see what you can do on your own for example 3. On example 3, we have a riverboat travels an average of 14 kilometers per hour in still water. The riverboat travels 110 kilometers east up the river and 110 miles west down the river for a total of 17.5 hours. To the nearest tenth, what is the speed of the current of the river? All right, so we have upstream and we have downstream. Each way has a distance, a rate, and a time. They tell us that the riverboat can travel 14 kilometers per hour in still water. So 14 and 14. When we are going upstream, we are going against the current. So the current is going to slow the boat down. So we're going to subtract R here because it's slowing the boat down because we're going against the current. When we are going downstream, the current's going to help the boat along and make the boat go faster. So here we're going to have plus R. Remember, it's always your boat first, then either plus or minus the current. They tell us that the boat goes upriver for 110 kilometers and downriver for 110 kilometers. And we don't know what time it takes each way, but we do know the total time. So just T and T. If I have distance equals rate times time, I can solve for time by dividing by R. So distance over rate is your time. So the time that it takes to go upstream plus the time that it takes to go downstream equals your total time. So let's look at upstream. For upstream, our distance is 110 divided by our rate, which is 14 minus R, plus downstream is 110 over our downstream rate, which is 14 plus R. And that equals our total time of 17.5. Now we are ready to find the least common denominator. So my least common denominator is going to be 14 minus R times 14 plus R. That is what I am going to multiply every term by. When I do that, 14 minus R eliminates with 14 minus R, leaving me with 110 times 14 plus R, plus 14 plus R divided by 14 plus R is 1, so that leaves me with 110 times 14 minus R, equals, I'm going to bring down my 17.5, 14 times 14 is 196, and then 14 times R is 14R. Negative R times 14 is negative 14R. And negative R times R is negative R squared. So from here, I'm going to go ahead and use my distributive property. 110 times 14 is 1,540 plus 110R plus 1,540 times or minus 110R equals let's see, 17.5 times 196 is 3,430. My middle terms are going to cancel. And here I'll have negative 17.5 R squared. So let's simplify this a little bit. 1,540 plus 1,540 is 3,080. 110R minus 110R cancels. And that's going to equal 3,430 minus 17.5R squared. Here I have a quadratic. I can solve this by taking square roots because I do not have a b term. And so I'm going to go ahead and do that. So I'm going to subtract 3,430. Oops, 3,080 minus 3,430 gives me negative 350 equals negative 17.5R squared. To undo multiplication, I am going to do division. And get 20 is equal to R squared. To undo the square, I'm going to take the square root. Now, typically we would have done birthday cake to simplify something like this, but writing our answer in terms of square roots does not make sense in the context of this problem. So I'm just going to type in the square root of 20 into my calculator, and I'm going to get plus or minus 4.5. Now, they tell us in the problem to round to the nearest tenth. Tenth is 1 decimal spot. So let's think about our answer. Plus or minus. Can the rate of your current be positive? Yes. Can the rate of your current be negative? No. So R is equal to 4.5. So that means that the rate of the current is 4.5 kilometers per hour. And then let's go ahead and look at our last example. It says Max can finish a report in 2 hours. Sam can finish the same report in 4 hours. How long will it take them to finish the report together? So Max plus Sam will equal their time together. So Max can finish 1 report in 2 hours. Plus Sam can finish the same 1 report in 4 hours. By adding them together, that will tell me that they can finish 1 report in X hours. So you're just writing proportions, right? 1 report in 2 hours, 1 report in 4 hours is 1 report in how many hours? So now that I have my equation, I can go ahead and find my least common denominator. My least common denominator is going to be 4x. So I'm going to multiply each term by 4x. So here I'll have 4x over 2 plus 4x over 4 equals 4x over x. So this will give me 2x plus x is equal to 4. So I'll have 3x is equal to 4. To undo multiplication, I'll do division and get x equals 1.3 repeating. Now, notice how I didn't leave my answer as a fraction. We're talking about hours. We don't talk about hours in terms of fractions. So it will take Sam and Max 1.3 hours, or 1 1/3 hours, to finish the report working together.